This question says that in a random sample of 160 occupational therapists, 23 know sign language. Let P represent the proportion of all occupational therapists who know sign language. Find the point estimate for P and use appropriate notation. Now, this is going to be a proportion problem. So, when we are asked to estimate a proportion, that is, finding the point estimate, we call this P hat. Now, to calculate P hat, we need the number of people who fit the description that we're after. This time, we're trying to find people who know sign language. So we're going to put the number who know sign language on the top. After that, we're going to place the total size of the sample on the bottom. The number of people who do fit the description is often symbolized as X, while the size of the sample is usually represented with N. Let's enter this into Excel. I'll call the number of people who fit the description X, and then I'll call the size of the sample N. My X are the 23 people who do know sign language. The total size of the sample is my total occupational therapists, or 160. We'll enter P hat into Excel. To find it, we say equals X divided by N. When we press enter, we get our point estimate of 0.14375. Now for part B, we are asked, find a 99% confidence interval for the true proportion of all occupational therapists who do know sign language. Then interpret this confidence interval. Now, to write a confidence interval, we need two things. We need a point estimate, P hat, which we have, and then we say plus or minus the error, the E. Now to find error, we need a fairly complex equation. Our error is going to be a number called Z critical, or ZC, times square root of P hat times Q hat divided by N. We'll need to go over how to get all of these figures. First, we know that N is the size of the sample. Thankfully, this was given to us. We already know it's 160. The P hat is our point estimate. We've calculated this already at 0.14375. Now, to get Q hat, we take 1 minus P hat. Let's do this in Excel now. We'll make a field for Q hat, and we say equals 1 subtract the P hat. When we press enter, we get 0.85625. Now, Z critical is a bit trickier. Now, the Z critical depends on the confidence. The Z critical represents the Z score when we cut out the middle 99%. That is because we have a 99% confidence interval. So let's draw a picture that represents that. If we want the 99% confidence interval, we are interested in the middle 99%. The Z critical is the Z score represented by this line on the right. That's the number we need to calculate error. Now, our confidence level was 99%, or 0.99. In statistics, it is oftentimes helpful to figure out a number called alpha, which is 1 minus the confidence. The alpha region would be these little tiny green tails that I'm drawing now. That is everything that's not included in the 99%. We can find z critical after we find alpha by using this formula. Negative norm S inverse of alpha divided by 2. We divide by 2 because we have two tails of equal size. So, I'll demonstrate how to enter this into Excel. We'll make a field for confidence, a field for alpha, and a field for z critical. The C is the confidence level, that's 0.99. The alpha will be 1 minus that confidence. This tells us how much is in the tails. And then for z critical, we say equals negative norm S inverse of alpha divided by 2. And now, after all of those calculations, we have a z critical value of 2.57583. Now that we have all of our numbers entered into Excel, let's mark what we need so we don't forget. We'll need the p hat, the q hat, the n, and the z critical. Now we'll place those into the formula for error that we wrote previously. We'll say equals, click on the z critical, and multiply times the square root of p hat times q hat divided by n. With all four numbers in the formula, we press enter. And we get 0.07144 for our error. Now that we have our error, we get the upper bound and lower bound. Remember, our upper bound is the point estimate plus the error. In terms of what we've done, that is going to be p hat plus e. For our lower bound, we will do p hat minus e. We'll make some fields in Excel for that as well. So for our lower, we'll say equals, we click on the p hat, and we say minus the error that we found. This will give us a lower bound of 0.07231. For our upper bound, we'll take our p hat and then add the error instead. This will give us 0.21519. These will be our answers for this problem. Now, to interpret this confidence interval, let's take a reminder about what we were trying to find. We were interested in the occupational therapists who know sign language, and we have a 99% confidence interval. We can say with 99% confidence that the true proportion is somewhere between these numbers. Now, when you write your answer, make sure you mention the confidence level. Make sure you also mention the thing you're trying to measure. And make sure that you put your confidence interval inside of a pair of brackets. So let's review what happened here. We were given an x and an n. Based on the x and n, we found p hat, and then based on the p hat, we found q hat. We were also given a confidence level. Based on the confidence level, we found alpha, and based on alpha, we found z critical. Now, using the n, the p, the q hat, and the z critical together, we managed to calculate the error. And then once we know the error, we can find our lower and upper bounds. So it's important to gather up everything you know before you start and remember what order to do the problem in. The first thing I would do is get Q hat and P hat. Then, using your confidence, follow this pattern from confidence to alpha to Z critical. Once you've gathered all of that up, you can find error. Then once you have error, you can find your lower and upper bounds.